All right, so I'm calling this the Wegmans problem. Wegmans is a grocery store here in the Northeast, and some places moving down south, maybe, I don't know. I know they're from New York. I was in line today. I asked the cashier, we were just talking, and then somebody next to us, one of the other cashiers, started talking to me about young people. So I was saying, like, young people in the grocery store, the ones who are the cashier, sometimes when I buy these gourmet burgers, they stack them sideways so they get deformed. And I said, you got to tell them to stop doing that. And one of the cashiers said, well, it's because of items per minute. So the IPM, so they're trying to reach the most items per minute. So they're just bagging as quickly as they can. It's like they're competing with each other. So then that made me think about Poisson distribution. And I asked them, well, what are they trying to shoot for? The one cashier told me they were shooting for like 20 items per minute. That's a lot. I said, is there an average? So I started thinking about my courses and lambda, the rate parameter for the Poisson distribution. And she said it's about 11 per minute. I said, I can calculate the probability of hitting 20 per minute with this information. So let's go ahead and do this. So this is a Poisson process, and I'm going to ask what's the probability that X, which is this IPM, equals 20 per minute, right? So this is the equation or the probability mass function for the Poisson distribution. It's lambda to the X, and again, X in this case is going to be 20, e to the negative lambda, and lambda is 11, our rate parameter, divided by X factorial. So let's just plug in the numbers. We get 11 to the 20, e to the minus 11, and then 20 factorial. So when we do this, you get a lot of large and small numbers here. So we get 6.721 E 120. So this is just, 20, not 120, 20, move the decimal place, scientific notation, right? Decimal place 20 places to the right. It's a large number. Denominator, we get 2.4329 E18, right? And then here we have for e to the negative 11, that's Euler's number in this case, right? It's 0.0000167. When I carry this through, I get 0.00462. I multiply this by 100, I get there's a 40.462% chance that somebody can hit 20 per minute, items per minute with this specific rate parameter. So that's for my Wegmans fellows there. Should pay me for doing this. Don't forget to subscribe to my channel. Thank you. Bye.